Hello guys, welcome to my YouTube channel. In this lesson, we are going to learn how to solve absolute value inequalities. We will solve algebraically and then try to show the results or try to show the solution set graphically. All right, let's go. Okay, so we have learned how to solve uh, equations involving absolute values, so it should not be that bad. This can be compared to x plus 6 with absolute value equal to 8, right? And then we usually would solve it like x plus 6 is equal to 8, which will be the first case. And the second case will say x plus 6 equal to -8. So this is how you would solve it if you have an equation, right? And it's still similar ways when you want to solve inequalities. So how do we do this? To do this, the strategy is to not have the negative on the right-hand side. So instead of writing this, for inequalities, you would have done negative of x plus 6 is equal to 8. So you want to keep the right hand side the same because you have inequality and direction really matters, in this case. So this is what we're going to do. That's the strategy we're going to use. And we also want to know that whenever we have a less than in what we're solving, our solution is going to look like, it's going to be like an interval like that, where you have maybe negative a here and a here. I'm just saying, so a can be any real number. So your solution is always looking like this, or x would be in between uh, this kind of numbers, okay? Yeah, they may not be, you may not have a negative number, but x has to be in between. So it's always like this kind of interval, like open intervals, okay? We have less than. So let's go ahead and solve this problem so that you can see the picture of what I'm trying to explain here. So I'm going to remove all of these so that we can have enough room to show our work. All right, so let's get started again. All right, so to solve this problem here, I'm going to have a case 1 and switching my colors to say green, I'll have case 2. Now, my case 1 will be just what I have here, okay? That's x plus 6 is less than 8. And my case 2 will be the opposite of that. So which means negative of x plus 6 is less than 8. This is what I am suggesting, okay? So from here, from the case 1, I can easily just solve by subtracting 6 from both sides. So let's do that. I'm going to subtract 6 from here and subtract 6 from the other side. So I'm going to cross this out and I'm having x is less than 2. This will be the first solution set. And you're going to go to the green one and solve. So but here you have to distribute your negative sign, okay? Remember, you have to do this right. So I'm going to distribute across my negative sign, because this negative just means like -1. Just imagine that you have an invisible 1 to multiply. So if I fix that 1 over here, okay, it'll be -1 times x, it'll be negative x. -1 times positive 6 is -6, and still keep your sign as less than 8. All right, so from here, one thing I can do quickly is to just add 6 to both sides. So you can see how I'm doing the opposite stuff, okay, because this is absolute value and you have reflections. Okay, so we're doing opposites. So I'm crossing this out. I'm going to get negative x is less than, this result here will be, again, it'll be positive 2. All right, so this is what we have so far, so good. Okay, so the next thing I'm going to do here is, oh, look at my mistake here. I'm supposed to add 6 to both sides. Let's go ahead and add 6 to both sides. You see? All right, let's do that. I'm not going to re-record this one because I just want you to see what mistakes we can make and how we can fix them, okay? All right, so let's take this away and go back to my 14. All right, so this is what I have. So from here, I'm just looking like, what should I do here? And I'm going to remember that for inequalities, if you want to get rid of negative numbers, okay, like this one, like we have here, negative x, you have to divide both sides by -1, okay? Or you multiply both sides by -1. That's how you can get rid of that negative to get x. So doing this will make us flip the sign. You have to flip your sign. So I'm going to put over -1 over -1, but I am going to have to flip the sign here. So let me use a different color. This sign here should be flipped. So I'm going to cross it out and I'm going to flip it to make it greater than now. You know with me? So now I have x here because negative goes away with this negative. X divided by 1 is just x. And then here I'm going to have 14 divided by -1, which is -14. So this is what I get as my second solution set. So remember this rule, okay? When do you flip the sign? When you divide by or multiply by negative coefficients of x, okay? If you're adding negative numbers to both sides or subtracting negative numbers from both sides, you do not flip signs. All right, so these are the two solution set that I get. Now I have to combine them to get an interval, okay? Now, we can combine these two statements to get a single interval. So this is what I'm going to do. So I'm going to have x is greater than 14 first. So I'm going to write x in the middle, this x, and this x would overlap, okay? And then I'm going to have my greater sign to the left and put my -14 and have my less than 2 right here. So this is how it makes sense algebraically to combine them. They're called compound inequality, okay? I have them combined like that. So you can see if x is less than 2, it is represented here. You can see that here. If x is greater than -14, reading it backwards also makes sense. So you have that. So this simply means that you can write your solution like this, -14, 2. And if you wanted to graph this, and if you check on decimals, make sure you always check on decimals. Just plug the whole thing, entire thing in decimals, and you're going to see your equation, your solution set looking like that. So you're going to have -14 over here, and then you're going to have +2 over here, and then you're going to see dashed lines because you have less, strictly less, and strictly greater. So you're going to have dashed lines, not solid lines, and then it'll be shaded in between. The in between will be shaded, it will be dark. So just check this out in decimals, okay? So this is your x and that's your y right there. So this is how the picture looks like. All right, let's go ahead and look at the second problem here. For the second problem here, the solution will be very different. It will be different than when you have it less than. So it will be the opposite of that. So which means one of the solutions goes to the right, to the left, and the other solution goes to the right. So this is how it will look like. So meaning that your solution will be, it will have a hole, like a gap in between. So let's just do this so that you can see what I'm talking about. Let's go ahead, I will take this away and then get started quickly. So from here, I'm going to have case 1 and case 2 again. My first case will be this. It will be 5x minus 3. That's your case 1. Okay, is greater than or equal to 12. Case number 2 will be when I do the opposite of what I have on the left. Okay, it will be negative parentheses. See how I'm using parentheses, right? So because you're doing the opposite of the entire thing. So keep it the same way, just the same. So the only thing I've introduced is the negative sign. So now I'm just going to focus on the first case and just solve it down completely, okay? So now what do I do here to solve my variable? So what I'm going to do here is add 3 on both sides and add 3 here. Cross this out. I have 5x is greater than 15. Easy. I can do this. So I'm going to divide both sides by 5. Divide by 5. Cross that out. Get x is greater than or equal to 3. Keep this one here. That's your first solution set. So we're going to move to the next one. So for this one here, we have to distribute the negative just like we did here. So distribute your negative across. It will be -5x. Distribute your negative to negative. It becomes positive. 3 is greater than or equal to 12. Now, next thing I'm going to do is to subtract from both sides. So I'm going to subtract 3 from here, subtract 3 from there, cross out, and bring down my 5x is greater than or equal to, that's going to be 12 minus 3, that's 9. Easy. So next thing I'm going to do here is to divide both sides by -5. So now, dividing both sides by -5 will make you want to flip the signs, right? Remember to do that. So I'm going to divide both sides by -5, divide by -5. So I'm going to flip the sign here, and it will change to a different, it will now become less or equal to. So now, cross and cross, I'm going to get x is less than or equal to -9/5. Okay, and we can do this now. We can do this, and you know, I think that gives a negative 1.4, 1 point, yeah, 1.4, if I'm not mistaken, or 1.8, yeah, maybe 1.8. All right, yeah. Okay, so let's leave it like this. Okay, so this is what we're going to do now. We need to look at how we can combine those, and you can see what we have here. You have x is greater than or equal to 3, and x is less than or equal to negative 9/5. So in trying to combine this, you will now be able to get it into a single compound inequality like we had here. This one here is just like a compound inequality. This one. We could combine them and have x in the in between, right? And it still makes sense algebraically. But this one is not so. You can see that x is greater than or equal to 3. So if you graph it, you see that the solution, you see that this set, they don't come together. So let me show you what I mean. So what you have here is, like, suppose you have a graph like this and you're trying to graph this, okay? I mean, if you compare that with this one here, you can see that you have here, you have x is less than 2, right? X is less than 2, which means you have 2 here going to the left. Less than 2 means you're going to the left from x. Okay, from 2 here, you're going to the left. And then from negative 14, you're going to the right because you have greater. So if you're going to the right here, so they will coincide here. And that's why we have to shade in between, right? But if you look at this one here, you have y here, you have x here. So let's look at the first result. You have 3, which is 3, right? And maybe somewhere here. And you have negative negative 9/5, maybe somewhere here. Because if you divide it, you're going to see what they're talking about. It's going to be negative 1.8. So from that, and then you're like, okay, how do I graph this result? So the first one is greater than 3, which means it's going all the way to the right. Greater means to the right. Greater, greater. Shaded all the way to the right. Shaded all the way to the right. You can see all the way. And then if you look at the second one here, it says less, which means all the way to the left from here, all the way, including the endpoints, including the numbers, because they're also equal. So all the way. So that's why when you graph this, you're going to see the solution departing from each other, like they don't combine. And you're going to have in between, a gap in between. And this gap in between is called union. Okay? Union. So which means you cannot put the solution together. You can't make it into a single compound inequality. So what you can do here is to write them separately, okay? So the first solution will be like that. So it includes 3 and is greater. So you're going to use square brackets and take it all the way to positive infinity. See that? But infinity is captured with what? Open brackets, okay? That's how you do it. And for the second one here, going all the way to the left, so you're going to point it in the direction of what? Negative infinity, coming down to what? Negative 9/5. There you go. So that's how you have them. So you can combine these two here. Combining them together, you now use the symbol for union, which is the symbol like this. Okay, so it will be to start with the negative first. I will do that. Negative infinity, comma, negative 9/5. Then I have to use since it includes the endpoint here. Look. This one here, it has less or equal to, so I can do square brackets here. Square brackets, okay? Square brackets. So I do square bracket here, then I put union and have the second solution right next to it. This one right here, it will be like this, 3 positive infinity. So we do not use square brackets for infinities, okay? Because infinities are not real. They're not real. All right, so this is how your solution set would look like. And if you try this out in Desmos, you would see that this is exactly the picture that you're going to get. And I hope this helps. And I'll see you in the next lesson where we will be solving inequalities involved in their quadratics. Okay. All right, let's go.